Hello, everybody. My name is Danko, and I will be giving a lecture on the nature of intelligence. Hopefully, there will be more lectures than one. This is the first one. And in this first one, we will talk about the difference between human intelligence and machine intelligence. That's going to be very interesting, I think. But before we start, I want to say a few words about me. I am a neuroscientist. Have been neuroscientist for many years, running a lab, neurophysiological lab, a real lab with real electrodes in the brain of animals, recording the activity. I also studied many years human cognition, like working memory, attention. We will hear today about working memory quite a bit. After that, I started doing more work on machine learning. As a matter of fact, I started with machine learning before becoming a neuroscientist. Then I was disappointed with how machine learning worked, so I moved to neuroscience to understand better how the brain worked in hope to improve machine learning and artificial intelligence. And one day I said, yeah, I got enough. I know enough about the brain now. Let me go and mess with machine learning and AI. In the last few years, therefore, I am working in this field, working with companies, working with startups, developing new types of AI, advising companies on how to build AI, using my knowledge from neuroscience, brain behavior as much as I can. My goal today is to tell you about the nature of intelligence. Nature of intelligence is something that you don't find usually in the classes of machine learning. In the classes of machine learning, you would usually just start with machine learning, right? You would go and learn some basic steps on, say, pattern recognition or basic steps on clustering. You would go into some equations and you would go and learn machine learning. Now, understanding generally about how intelligence works, what is intelligence about, should be very helpful, I think. Because if you know general stuff, you can use that knowledge in your everyday work with machine learning, for example, and make decisions and hopefully make some wise decisions about things. So you don't, for example, overestimate the power of your algorithm. You don't get over excited that you can solve some problem that basically maybe cannot be solved. And how do you know if you don't have a general knowledge? If you do have a general knowledge, maybe you have a possibility to answer that question, maybe calculate something, maybe think about some ideas. Does this apply to that theorem? Does this, and exact, it doesn't look like this problem could be actually solved easily. These kind of things I would like to know. That's very useful. And the interesting thing is that, as we said, classes of nature of intelligence don't exist in machine learning as far as I know. Maybe this one is the first one ever. The reason they don't exist is because nobody knows much about the nature of intelligence. That's easy. That's a simple reason. But why am I talking about it? Well, because I worked on the nature of intelligence in the last few years. That's where I put a lot of effort. As I made my shift from neuroscience to AI, I actually worked on the problems of nature of intelligence. Use my neurophysiology knowledge, use my working memory knowledge, and developed quite a bit of work in theory and ideas. And that's what we will talk about. We will talk about these ideas as well. But today, first, we will talk about some basic, some elementary stuff from cognitive science, from neurophysiology, in order to understand basic differences between how machines work and how human minds work. So let's start with that. So machine learning versus biological intelligence. Where is the difference? Now, we could think like this. Our human intelligence is quite related to the intelligence of other animals. Like a dog, think dog, think cat, think monkey. Actually, there's not much difference between our intelligence and animal intelligence. Yes, we do look much smarter. We have entire civilization, we have a language, we have mathematics, we have machines, technology. They have none of it. And yet, there's a lot of similarity. There's just a small difference between our intelligence and their intelligence. But more important is that our intelligence came on top of their intelligence. Whatever they have is what our ancestors had some millions of years ago. And then evolution did some good job coming up with some few new twists to the genes. And then suddenly, on top of whatever animals have, poof, came human intelligence, came a civilization. Wonderful. Why is that important? Because machines have none of it. Machines don't have this background. Machines start with intelligence that is not that smart. You don't believe me? Think about it. Compare a real dog with a robot dog. Who do you feel is smarter, more intelligent? Who can do more things wisely, smartly, correctly, behaving in the environment? I think the answer is pretty easy. The real dog. The things that real dog can do are actually quite impressive. No robot today can even approximate what they do. First, perception, pattern recognition. How many different things can a dog recognize reliably? Learn quickly. Locomotion, keeping balance, moving body, jumping, chasing balls, chasing prey if necessary. They don't need to do it anymore, but they could if they needed. They use these skills to play rather than hunt. Excellent skills. A dog robot or any other robot is just gonna walk like a robot. How robots walk, we know it's not good. What else do we have? Perception, we have locomotion, we have understanding of a new situation. You put a dog in a new room, never been before. The room may be complex with obstacles, with possibilities.